Good morning, everybody. How are you? Today we are gonna learn, or we're gonna revise all of Unit 10 lessons. So let's step by step discuss and remind all of the main points and main skills that are included in this unit. So in Unit 10, we learned the first lesson, what is electricity. So this is the first lesson that was included in this unit. What is electricity? And this lesson, we began with atoms. And we said atom is the smallest component of matter, or we can say the building block of all matter. Then this atom includes two main components. The first component of atom, we call it nucleus. A nucleus is the center of an atom, and electrons move around nucleus. So we said atom is the building block of all matter, then it includes nucleus and electrons move around it. And electrons move around nucleus in an area, we call this area electron cloud. An electron cloud is an area around nucleus. The probability of finding electrons in this area is high. Then, nucleus includes two main components. It includes protons and neutrons. So, protons and neutrons found where? In nucleus. Nucleus and electrons make an atom. So, from the smallest to the largest, or from the largest to the smallest, atom includes nucleus and electrons. Nucleus includes neutrons and protons. The charge of proton is positive. The charge of electron is negative, and the charge of neutron, no charge, neutral. The charge equals 0. Then we continued how to find the total charge of an atom. How to find the total charge of an atom, and we said we have three different cases. The number of electrons equals the number of protons. Means, for example, 4 electrons and 4 protons. Here means the charge equals 0 because 4 positive and 4 negative, 6 positive, 8 positive and 8 negative, the same. So if we have the same number of electrons and protons, so the charge equals 0, and we call this atom neutral. Then the second case with losing, and third case with gaining. And we said here to find the total charge of an atom. Here with losing, we have losing, and gaining will be what? With only electrons, because they can move, and protons and nucleus. So losing and gaining with electrons. So with losing, so this number will decrease. So what will happen? Positive charge will appear. And with gaining means we added extra negative charges. So with losing it will be positive, and gaining it will be negative. And we said, for example, if an atom lost 2 electrons, means positive 2. If it gains 2 electrons, negative 2. So if it loses 2 electrons, positive, with losing positive, then 2. If it gains 2, gaining means negative, negative 2, like this. After that, we continued with static electricity. Or in this way, we said here, electricity we can divide this electricity into two types, static and current. Static and current. And we know static means it's not moving. When these charges move, these charges means positive and negative. If we have no movement, we have static electricity. If we have movement, we have electric current. So what is static electricity? And we said before, static electricity means the buildup of charges on an object. The buildup of charges on an object. When we add extra electrons to the surface of an object like balloons, this is what we call it static electricity. Okay? Then, electrostatic discharge. When these electrons, sometimes when you touch your friend, you will be shocked. Or if you touch the hand of the door, you will be shocked with a small electricity. Why? Because of electrostatic discharge. Because of electrostatic discharge. Static means adding. The jumping of electrons from one object to another, this we call it electrostatic. Electrostatic discharge. So we have static electricity, it means building up the buildup of charges on an object, adding extra electrons to the surface of an object. Then electrostatic discharge means the jumping of electrons from one object to another. Then when these charges flow through wires, we call it this electric current. What is the electric current? The flow of charges. The flow of charges through wires. So the flow of charges through wires, this is what we call it what? We call it electric current. So till here we finished the first lesson in this unit about atoms, and you were here when we took this lesson. Then the second lesson about in this unit we continue the conductors, insulators, I mean electric conductors and electric insulators, then electric circuits. Okay. So we said electric conductor, so conductor means what? Conductor means is a material that allows electric charges to flow through it easily. So as I said, like heat, we can define conductors. Instead of heat, you can say electric charges. So again, conductor means a material that allows what? The flow of electric charges. So that allows the flow of electric charges. And we know most metals are good conductors of heat, and we said good conductors of heat are good conductors of electricity. The second one, insulator, and we said insulator means a material that doesn't conduct electric charges, or it resists the flow of electric charges. Plastic, rubber, and foam and sponge are examples of insulators. Then we continued with circuit, and we said don't mix between circuit and current. We said don't mix between circuits and current. So current, electric current I mean, and electric circuit. And we said current means the flow of charges through a path of wires or conductors. The flow of charges. And circuit means the path that electric charges can flow through it. So easy here. The path we call it circuit, and the flow of charges we call it current. So if we have a simple circuit, then we added, for example, or light bulb anywhere here, for example, or I'll add like this again. So, for example, if we have an electric circuit, and then I'll put a light bulb here, the same, okay? So, this path, so we call, listen up, these wires, we call it circuit, but the charges inside the wires, we call it current, okay? Don't mix. Then, to make a simple circuit, we know we need battery or source of energy, we need wires or good conductors, we need a switch, and we need light bulb. The job of battery to provide this circuit with electric charges, then wires to conduct electric charges, then switch to open and close the circuit. When we close the circuit means the light will work. And this circuit is open circuit. Now it's open circuit, and with open circuit no light. So battery to provide the circuit with electric charges, wires to conduct electric charges, and light bulb to change the source of energy. Then after circuit, we continued with two ways of connecting electric circuits. And we said we have two ways to connect circuits. The first type of circuits, we call it parallel. Parallel circuits and series circuits and series. So we have parallel and series circuits, two way of connecting circuits. How we can differentiate between, easy to differentiate between each type or to connect each type. Series, from this name, from its name we know they are beside each other in order, so it includes, it has one path of electric charges. For example, battery, then wires, then switch, for example, then light, the first light bulb, the second light bulb, for example. So in this way, electricity will move in one path, the first, then to the second, then when we close the switch, till here. So electricity can flow in one path. So, and we said before, if one burns out, what will happen? So, like open circuit, it will not work, the other will not work. So if one burns out, if one burns out, the others will not work. So this is the first type of circuits. We call it series circuits. The second type of connecting devices, parallel circuit. In parallel circuit, so in series we have what? One path. In parallel we have several paths, more than one path. So electric charges can flow in more than one path. How? So this is the battery, for example, then positive and negative. For example, like this. Then each light bulb will be connected with positive and with negative. The second one with positive and with negative. So if this, when we close the circuit, if this is not working, means burns out, this will work because nothing will open this branch. So this branch, electricity will stop here because open circuit it will not move. But in this branch, it will move. We have closed circuit here. So if one burns out, if one burns out, the others will stay working. So parallel circuits better than series circuits. And we use in our houses this way of connecting devices. Then we continued with circuit breakers and fuses, and we said circuit breakers and fuses are used in our houses and our expensive devices. Why? To protect our expensive devices. When electric current comes too high, it will open the circuit. When electric current comes too high, it will open the circuit. So they protect our devices, or they prevent electric current when electric current comes too high or comes irregular, so when electric current comes irregularly, they open the circuit. If they open the circuit, so electric charges cannot reach to our devices or they not make fire. So this is the second lesson that is included in this unit. Then the last lesson that we learned about it in this unit, I mean, how we use electricity. How do we use electricity? And we began in this lesson with uses of electricity. And we said we have many different uses of electricity. We use electricity every day, and using electricity makes our life easier. Okay, like it's used in all of our devices. So all technology depends on electricity like this. Then we continue with electric generator and electric motor. And we compare between generator and motor. And we said its name generator, so it generates electricity. So the first one, generator, it generates electricity. It generates electricity. The second one, motor, it uses electricity. Then here it changes which form to which form. To generate electricity, in the first term, we learned about green energy, and we said the green means clean, to producing or to generating electricity from sunlight, wind and water. They will not make pollution. So, or by burning non-renewable resources like burning fuel, and this way is used nowadays here. So, it changes which form to which form. It changes mechanical energy, because generator, it generates electricity by motion. So mechanical or kinetic energy into electrical energy. Motor, it needs electricity, like fans, like any device that includes fans. It needs what? Electricity. So it changes electrical energy into mechanical energy. And here, like to generate electricity, we have pictures in our book, like windmills, like hydroelectric generators. Then we continued with magnets, magnetism and magnetic field. And we said magnet is a material that attracts iron and a few other metals. And this magnet includes two ends. This magnet includes two ends. So the magnet includes what? Two ends. Or we call these ends poles. north and south poles like Earth. North and south poles, so the same meaning, because gravity, it looks like what? Magnetism. So it includes two ends, north and south, and we said like poles means north with north and with n repel. If we have n, and the second one is they attract. So if we have like poles, n or ss, they repel. If we have opposite poles, ns or sn, they attract. So attraction occurs with opposite poles and repulsion occurs at like poles. Then we said magnetism is a physical property of magnet, means this power we call it magnetism. Then later you learn in Unit 7 about physical property. And physical property means a characteristic that we can observe it or measure it directly. Then magnetic field. Magnetic field, and we said now, magnetic field we know some, you don't need to put the nail here to be attracted to this magnet. Maybe from here it will be attracted. Why? Because the force of this, because of the force of this magnet. So, there is an area around magnet. This area, invisible area. This area, invisible area. It can attract, or the magnetism appear in this area. This area we call it magnetic field. So magnetic field, an area around magnet. This area around magnet where the power of this magnet acts, or where magnetism or where this force acts. So this area we call it magnetic field, and the strongest magnetism will be here and here, means with poles, and the lowest will be in the middle, so like Earth too. So we said magnet is a material that attracts iron and a few other metals. Then magnets have two poles, NS poles, or north and south poles. Then like poles repel and opposite poles attract. Okay? Then magnetism is a physical property of magnets. Magnetic field is an area around magnet where the power or where this force acts, and this force, invisible force. To see this force we use metal or iron powder. Then the last point we skipped it like the first live the previous lesson. Electromagnet, sorry. Electromagnet means as a device that uses electric current to produce magnetism. So, its name electromagnet, as a device that uses electric current to produce magnetism. It uses electric current, like jack current, to produce magnetism. So this is the meaning of electromagnet. We can make this magnet in our houses. So what is an electromagnet? A device that uses electric current or electricity to produce magnetism. Like jaguars, and we know jaguars are used to carry or to carry old cars from one area to new areas. So this is the second or the third lesson that is included in this unit about magnets and about electrical generators and electric motors. Till here we'll stop with Unit 10, then see you in next lesson with Unit 11 review. Stay with me.